So here's an example of how to use Snell's law. I'm working from Louis, page 372, chapter 15. I'm going to do questions 7 and 8. Question 7 says, light travelling from water into glass is refracted at an angle of 49 degrees. At what angle was the light incident upon the glass? So let's start by drawing ourselves a diagram. We have water and glass. Now water's refractive index is 1.33 and the question says the glass is 1.53. Light is incident from the water into the glass. The glass is thicker than the water, so it's going to bend towards the normal. Coming in, here's my normal, and the light is going to bend towards the normal. Okay? It's refracted at an angle of 49 degrees, so my diagram was a little bit misleading. It's really more like that. 49 degrees was the refraction angle. Remember, that's the angle from the normal, not the surface. We have to work out the angle of incidence here, I. So let's use Snell's law. N1 sine theta 1 is N2 sine theta 2. N1, first refractive index is 1.33. Angle of incidence is what I'm looking for, sine I. Second refractive index, 1.53. Angle of refraction is 49 degrees. I'm looking for I. So first get rid of 1.33 by dividing by it. 1.53 times sine 49 degrees divided by 1.33. Some people try to work this out as a decimal, then they usually round off too much. Don't. Leave it as a sine of an angle until the very end. Okay, pardon me. If that's sine of I, then I must be inverse sine of all of that. 1.53 times sine 49 degrees over 1.33. Let's type that in carefully on the calculator. You can do it in one go. 1.53 times sine 49 divided by, close brackets, divided by 1.33. And I, as it turns out, is 60.25 degrees. Okay, let's try question 8. If a laser light is shone onto a pool of water at an incident angle of 15 degrees to the normal, what will be its angle of refraction? So again, let's draw a diagram. This time I've got air with refractive index of 1 and water, which is 1.33. Light is incident at 15 degrees to the normal. 15 degrees, always to the normal. What will be the angle of refraction? Well, again, it's going from thinner into thicker, so it's actually going to bend towards the normal. Let's put that in, R, angle of refraction. Snell's law, N1 sine theta 1 is N2 sine theta 2. N1 air, 1.00. Sine of the angle of incidence, N2, 1.33, times sine of R. Okay, I'm looking for the angle, so first divide by that. I can ignore 1.00, it's not going to change anything. Sine 15 over 1.33 is equal to sine R. And if that's sine R, then R must be inverse sine of what I've got there. So R is inverse sine of sine 15 degrees divided by 1.33. 11.22 degrees.